Nvidia just surpassed the $5 trillion market cap, making it the world's most valuable company, and the first in history to reach this milestone. Their data center revenue alone hit $30.8 billion in a single quarter. Microsoft, Google, Amazon, Meta, they're all buying up everything and anything Nvidia can ship. So why then can't anyone compete with Nvidia? And why are Nvidia's chips in such demand that in China there's now an unprecedented black market for chips? Intel has been making chips for over 50 years. The Intel Inside jingle was as distinctive to my generation as the Nokia ringtone or the Microsoft paperclip. AMD also has competitive products. Historically, this was their chips for gamers, and yet Nvidia's market share in AI chips is between 85 and 90%. So what's going on? The conventional answer is CUDA ecosystem lock-in, aka Nvidia just makes better software for the chips. But that's not the real answer. The real answer is infrastructure, and it's a story about one packaging technology, 3 separate bottlenecks, and why even losing an entire country's market has not slowed Nvidia down. I'm tech journalist and AI consultant Harry Verity. If you're enjoying this video, do like it and give us a sub, which helps us grow, and even leave us a comment. Let's start by laying out how dominant Nvidia actually is in late 2025. Some of these incredible numbers. They have a market cap of $5 trillion, that's the world's number one. Their Q3 fiscal 2025 revenue, $35.1 billion, that's up 94% year over year. They have a data center revenue of $30.8 billion in one quarter, that's up 112% year over year. Their AI chip market share, as we discussed, was 85 to 90%, and their stock performance is up 50%. To put this in perspective, Nvidia's data center business, just one division, generates more revenue per quarter than AMD's entire company makes in a year. Let's not understand just how successful Nvidia is. They are undoubtedly the most successful company of the 2020s. Every major cloud provider is all in on Nvidia. Microsoft Azure announced 200,000 H100 GPUs. Zuck said Meta would run 600,000 GPU units, and that was by the end of 2024. Amazon AWS committed to a $50 billion spend in AI infrastructure spending, and that was mostly going to Nvidia's chips. And Google Cloud, despite having their own TPUs, which we talked about in last week's video, are still buying massive H100s in volumes. Then there's the valuation question. Nvidia's PE ratio is around 59, that's high, but not insane for this growth rate. But here's what's wild. Investors aren't worried about competition. The stock keeps climbing because the market believes no one can catch up. So why is that true? Why, with unlimited money and motivation, can't anyone build a Nvidia competitor? If you search, why can't anyone compete with Nvidia, you'll generally get 3 standard answers. The first is Nvidia's CUDA software lock-in. Now, Nvidia's CUDA platform has 15 years of libraries, tools, and developer familiarity. Switching to AMD or Intel means obviously rewriting code. And this is true, CUDA is incredibly intuitive, and you can understand the learning curve and the hesitation to change. Millions of developers know this. Every AI framework is optimized for it, but it doesn't explain why competitors can't get any market share. AMD's ROCM is improving, Intel's One API exists. Software lock-in is real, but it's not the full story. Another answer you might get is better architecture. Now, the argument is that Nvidia's Hopper and Blackwell architectures are just technically superior. Of course this is true, Nvidia's Tensor cores, NVLink interconnects and memory bandwidth are the best in class. And of course you can deploy these Nvidia H100s from a data center of your choice very easily with G-Core. But AMD and Intel's chips perform well on specific workloads. The problem isn't that competitors can't build good chips, it's that they can't build enough of them. Another argument is that Nvidia just got there first with the A100, then the H100, and now nobody can catch up. Now this is partially true, but it's not the full picture. Being first of course matters in this game, but first mover advantage doesn't explain the 85 to 90% market share 3 years into an AI boom where everyone now knows the stakes. So these 3 answers are all correct, but they're symptoms, not causes. The real answer, infrastructure, specifically a packaging monopoly no one's really talking about. Here's one of the factors that's stopping a competition: the CoWoS monopoly. And CoWoS stands for chip on wafer on substrate. It is an advanced packaging technology that stacks the GPU die next to the HBM memory modules with microscopic, ultra short connections. Oh, why does this matter? Well, AI chips need massive memory bandwidth, terabytes per second, and the only way to achieve that is by placing memory dies directly next to the GPU with connections measured in microns. CoWoS is the only packaging process precise enough to do this at the speeds that AI requires. And here's the problem: only TSMC can do CoWoS at scale. Nvidia uses 60 to 70% of TSMC's entire CoWoS production capacity, but TSMC can only meet about 80% of the total CoWoS demand, and the current capacity is about 65,000 to 75,000 wafers per month in 2025. And the projections are that they'll be able to get to 90 to 110,000 wafers per month in 2026. So current demand far exceeds even these predictions. When AMD tries to compete, they need CoWoS packaging. When Google builds tensor processing units, they need advanced packaging. Everyone is fighting over the same limited resource. Nvidia locked up 60 to 70% of the supply years ago. And you may ask, why can't competitors build their own? Well, of course they are trying. Samsung has iCube and HCube. Intel has EMIB and Foveros. Amkor is ramping up as a CHIPS Act recipient, but they're all 3.5 years behind TSMC on things like yield rates, that's the percentage of chips that work, process precision, micron level accuracy, volume capacity, chips per month. TSMC is investing billions in new CoWoS facilities. New capacity won't reach full production until 2026, 2027. So even with 60% annual capacity expansion, TSMC says the bottleneck will last 18 months minimum, and that was their 2024 prediction. But ultimately, here's what Jensen Huang understands so well: the competition isn't just about designing better chips, it's about the entire supply chain. Nvidia secured long-term CoWoS capacity agreements with TSMC years ago, back when most people thought AI was just hype. And by the time other companies realized they needed the same packaging, Nvidia had already reserved most of the supply. But there are also two more choke points. Every H100 needs HBM3 memory, those stacks of memory dies we talked about surrounding the GPU. And only 3 companies make HBM3: Samsung, SK Hynix and Micron, and those guys can't scale fast enough either. SK Hynix is currently Nvidia's primary supplier. Samsung is ramping up production, but they're optimizing for their own customers. Now, you could of course solve the CoWoS bottleneck tomorrow, but you'd still hit a memory supply rule. Nvidia secured HBM3 supply agreements early, just like they did with the packaging, and the competitors are all fighting about what's left. So ultimately, here's what most people miss: you can't just ship a GPU. The H100 is an AI supercomputer. To build one of these requires server manufacturer, cooling system suppliers, power delivery components. Every part of that supply chain has to scale together. So much goes into making GPU chips optimized. Enterprises that are serious about scaling with AI, they're not ordering chips, they're ordering complete rack-ready AI systems. So we now understand the complexity of the problem and the key bottlenecks. But what about China? Some say AI is an arms race, even a new Cold War with China on one side and the West on the other. And this is where things get very interesting. After US export controls in April 2025, Nvidia lost official access to China. That's a market worth tens of billions in potential AI chip revenue. You've probably seen this had real world consequences. DeepSeek was forced to delay their R2 model due to the US export controls on AI chips, specifically the ban on Nvidia's H20 chips. Chinese authorities reportedly pressured DeepSeek to use Huawei as a Zen 910C chips instead of Nvidia hardware. And switching to Huawei's chips means rewriting everything, and their performance still isn't comparable. So DeepSeek went back to using whatever Nvidia chips they could get their hands on, which brings us to the black market. Despite the official ban, Nvidia chips are still flowing into China, just not through legal means. Some companies are using Singapore as their invoicing hub, but the chips are going elsewhere. And in March 2025, Singapore authorities arrested individuals allegedly involved in a $2 billion chip smuggling operation to China. Think about that, $2 billion from just one operation. Reports from China describe an entire underground economy, used Nvidia GPUs selling at massive premiums, grey market importers buying chips through European shell companies, Chinese data centers quietly stocking up on H100s and H20s before the ban. To make advanced AI chips, you also need extreme ultraviolet lithography machines, and only one company in the world makes them, ASML, based in the Netherlands. And ASML is banned from selling EUV machines to China. So what does that mean for the future? As long as AI models require massive compute, chips will be in more and more demand. Nvidia doesn't just make better chips, they control 3 separate irreplaceable parts of the supply chain. Even with TSMC expanding CoWoS capacity by 60% annually, their projected capacity of 90 to 110,000 wafers per month by late 2026. Morgan Stanley estimates global demand will reach 1 million wafers by 2026. Current demand is already 2 to 3 times the available supply. Remember, this is not purely about chips. We also need to be thinking about how we make better use of the chips we already have. And this is why edge computing and distributed AI matter, something that G-Core offers at scale, are important. Inference infrastructure is increasingly becoming the competitive advantage. Edge inference allows you to run smaller models closer to users. Distributed training means you can spread your workloads across multiple regions. A mix-owned infrastructure with rented capacity on the hybrid cloud. The companies winning the AI race won't be the ones with the most H100s. So here's my take. Everyone is asking the wrong question. The question isn't, why can't anyone compete with Nvidia? AI is generating unprecedented economic value. Let's break down some of these data points. ChatGPT hit 100 million users faster than any product in history. AI coding assistants are showing some 126% productivity gains in a lot of cases. Goldman Sachs estimates that AI will add $7 trillion to global GDP by 2030. The Nvidia shortage isn't a supply problem. It's telling us that the AI transformation is bigger, faster, and even more inevitable than even the optimists predicted. And infrastructure, edge networks, distributed compute, efficient deployment all play a major part, not just the pure hardware. And that, I think, is the real story here. What do you think? Is Nvidia's dominance permanent? Is the real answer distributed inference at the edge? Or do you think this could all come crashing down? Let me know in the comments. And if you've made it this far, hit the subscribe button. We're going deep on all the big questions in AI, computing and infrastructure every single week.